Okay, hello students. Now this video is regarding the part 2 for pressure control valves. In earlier lecture we have seen what do you mean by cracking pressure, what do you mean by full flow pressure, cracking pressure, full flow pressure. Then we have seen the working of the pressure relief valve. In that this is the direct pressure relief valve. This is its symbol. Then we have seen the pilot operated pressure relief valve. We have seen its working also, how pilot pressure relief valve exactly works, we have seen that. And now we are going to see the next type of valves. After pressure relief valve, one more valve was there, that is the unloading valve. Pressure relief valves are used to relieve the entire system from building up high pressure than the set pressure. Unloading valve is used whenever two pumps are there, one is the high pressure pump and one is the low pressure pump. Then at that time, whenever very high pressure gets developed inside the system, then low pressure pump unloaded through the unloading valve, or from the actuator side also unloading valve helps to reduce the pressure. So this is also again normally closed valve. We have seen the circuit for unloading valve also, two pump circuit. It is also known as the double pump or two pump circuit. Two pumps are there with low pressure and high pressure, and unloading valve is shown here, which is used to unload the low pressure pump. Okay, now after that we have seen the sequence valve. To sequentialize the operation, how sequence valve, pressure sequence valve is used. It is always associated with the check valve. We have seen the circuit of the sequence valve, clamping and then the tooling, that is the clamping of the job and then extension of the cylinder which is attached to the tool. So that sequence has to be followed through pressure sequence valve. So this is regarding the last video what we have revised. Now in this video we can start from the counterbalance valve. Now if you see the working of counterbalance valve, it is normally used to control the vertical cylinder, not to allow it to fall freely. Means what? Whenever the load, that is the actuator, the load is in vertical fashion, it is mounted vertically. Now suppose sudden power failure is there, what will happen? From the one end of the actuator, suddenly oil will be withdrawn back, and because of the self weight or inertia load, it will descend down directly. So to avoid its descending down movement and to avoid the damage or the accident problems, this counterbalance valve is used. It is also known as the back pressure valve. Now understand its construction, how it is constructed. Now you can see here in symbol, two pilot lines are there. One is direct pilot line, one is the remote pilot line. Whenever this valve is used as a counterbalance valve or back pressure valve, direct pilot line is used. Whenever at low pressure, remote pilot pressure is applied to connect this valve from normally closed to open, then it is called brake valve or safety valve. Now as usual to the previous valve, we can see here for pressure setting, set screw is there, spring is there to which spool is attached, drain is there. Now see, drain entry is there, as I explained you in earlier case, that is the drain is used to collect the leakage from the control chamber towards the tank. Collection of leakage oil from the control chamber towards the tank. Now two lines are there, whatever shown in a pink color, that is the oil line from the load side. Load side means actuator side, and at the left hand side tank is shown, that is the tank line is shown. Now Right now, because of the spool in between the load line and tank line, it is disconnected. That is the normally closed flow from the actuator side. Load means actuator. From the actuator side, that is the whatever oil is exit from the actuator from the load side is not allowed to pass towards the tank. That's why in vertical fashion that load cannot come directly in case of the power failure. Now there is a control signal line. Now whenever the proper power is available, means no power failure, and proper pressure is available such that that pressure is more than the spring pressure which is set in counterbalance valve, then only through control signal line this pressurized oil will try to push up the spool against the set spring pressure, and then due to upward movement of the spool that load line is getting connected to the tank line. Means what? It will allow the entry of oil from the actuator side towards the tank or towards the reservoir only when through control signal line enough pressure gets built up, and because of that spool can be moved upward against the spring force. Now in case whenever the same valve is used as the brake valve, or it is also called a safety valve, the set spring pressure is very less, not like the counterbalance valve, and through remote pilot line which is shown exactly below the tank line. Remote pilot line is there. Closed means right now it is closed whenever used as a counterbalance valve. Whenever it is used as a brake valve, through remote pilot line that much pressure is applied so that spool can be pushed in upward direction and load to tank line can be connected, that is to unbrake the valve. So this is the construction of counterbalance valve. You can see at the right hand uppermost corner its symbol, its ISO symbol. Now see, up till now whatever valves we have seen all are the normally closed. Normally closed means what? Its input and output is disconnected in normal condition. That's why from the input line and output line, that arrow, whatever arrow is shown inside the box, it is at some offset distance. So while writing the assignments, while writing the answer in the exam, please note that for all types of normally closed valve, the arrow should be at some offset distance. It should not be in line with the main line, then its meaning is different. So pay attention toward the symbol. Whenever remote pilot line is used, it is worked as a safety valve. Whenever direct pilot line is used, it works as a counterbalance valve. Now after understanding its construction and working, now we can move towards its applications. Now what are the applications of counterbalance valve? It is mainly used in forklifts to lift the heavy loads. That is, whenever load you have to move up and down in vertical fashion, this valve, use of this valve is must. It is used in JCBs, in earth moving equipments, and in hydraulic machines for particular applications. Now try to understand the circuit. Try to understand the circuit where counterbalance valve is used. Now you can see the circuit components. Very bottom most is the tank. After tank, pump is there which is run by motor. After that, pressure relief valve. After pressure relief valve, gauge is there. Then direction control valve is there. If you look at the direction control valve, it is solenoid operated 4/3 direction control valve, and then you can see from the rod inside and the direction control valve, in between that, in between the load, means in between the actuator and the direction control valve, counterbalance valve is fixed. Now This counterbalance valve is always associated with the check valve. Now you may have a question that what is the use of the check valve along with the counterbalance valve, or why to use the check valve. Why to use check valve? Okay, some some problem was there with my screen, so again some time I am resuming my video. Now why check valve to be used along with the counterbalance valve? That whenever upward stroke is required, then at that time oil should have its way to move from direction control valve towards the load. Means the entry should be possible inside the actuator. That's why this check valve is used, so that it can allow the oil flow from DCV, that is from direction control valve, towards the actuator. But whenever the flow is from load side, from actuator to direction control valve, that is the exit flow from the rod end side, it has to go through the counterbalance arrangement. Now what will happen because of the sudden power failure? Due to sudden power failure, what will happen? Whatever oil is there, whatever oil is leaving from the actuator, it is collected in between the counterbalance valve and check valve. As power failure is there, no enough pressure gets built up. So because of normally closed counterbalance valve, it will protect the downward motion of the load. And if no problem is there in the circuit, no power failure is there, and when enough pressure is developed, then only enough back pressure is developed, then only through pilot line it will develop that much pressure, and normally closed valve will be in open condition and it will connect the flow from actuator side towards the tank. So this is the working of counterbalance valve. Counterbalance valve is also a normally closed type valve, and it is always associated with the check valve, just like the pressure sequence valve. And whenever the remote pilot line is used, that counterbalance valve can be used as a brake valve or safety valve. Now here it is shown the two positions, that is the vertical load and it is along with the counterbalance valve. In left hand side you can see the counterbalance valve is normally closed, and in the right hand side, whenever the enough pressure gets developed, then only through remote line it is getting connected, and then only its downward motion is possible. So two positions have been shown here, when valve is closed and when valve is open. It is a normally closed valve, means left hand side position is the normal position. Now next valve is the pressure reducing valve. The name itself implies that it is used to reduce the pressure. Means what? Because of the constant flow or constant discharge of the positive displacement pump, it develops some pressure inside the hydraulic system. But many times, for many applications, it finds that very less pressure is required during some stroke or during some particular application. So at that time, at the actuator side, it is required to control the pressure. It is required to provide the exact pressure as per the requirement. So at that time, the pressure reduction is the required. For that, this pressure reducing valve is used. Now you can see here a symbol and construction of the pressure reducing valve. Now first look at the upward right hand side, its symbol. Here arrow is in line with the main line, means what? It is normally open valve. Up till now, whatever valves we have seen, pressure relief valve, sequence valve, unloading valve, counterbalance valve, all are normally closed valve. Pressure reducing valve is normally open valve. Means what? In normal condition, the main pressure line and the output line is connected. It is not in disconnected position in normal case. So this is the difference from the previous valves whatever we have seen up till now and this valve, pressure reducing valve. In construction we can see the screw is there to adjust the pressure setting on a spring as usual. Drain is provided. What is the function of drain? Function of drain is to collect whatever leakage oil inside the control chamber, to collect that oil and connect it to the tank. So in control chamber, leaked oil should not getting stored, so it should be diverted towards the tank. Now with the help of the pink color, it is shown that is the pump line or main pressure line, and in normal position that main pressure line is connected to the output line, that is the actuator line. Now one control signal line is there in the downward side which is connecting the output side and the spool. Now how to control the pressure? Question is that how to control the pressure? Now what will happen whenever the main pressure is more than the set pressure? When pressure inside the control signal line is more than the set pressure of the spring, what will happen? It will lift the spool against the spring pressure. Again I am repeating, whenever pressure inside the control signal line because of the pressurized oil is more than the set spring pressure, then it will lift the spool in upward direction against the spring pressure. Because of the upward motion of the spool, what will happen? It will block the passage between the main pressure line and the output line, and because of the blocking of the passage to some extent or full extent at the output side, we will get the throttled flow. Means we are getting some flow obstruction at the output side, and in this way by controlling it we can control the pressure. With the help of this valve we can get the reduced flow and reduced pressure at the output side. Again I am repeating, whenever the pressure at the output side is more, then what will happen? Inside the control signal line, that pressure built up is more than the set pressure on the spring. Because of that, it will lift the spool in upward direction. Because of the upward movement of the spool, it will block the passage to some extent between the pump and output side, between the main pressure line and the control pressure line, and because of the blocking of that passage at the output side, whatever full flow condition was there, now at the output side there is a condition of the throttled flow. Means what? Some obstructed less amount of flow will be there, and due to this flow obstruction at the output side the pressure gets reduced, and we can control the pressure at the output side. So this is the working of pressure reducing valve. Now what are the applications of the pressure reducing valve? It is used in air compressors, It is used in inlet of flow of load in pressure reactors, used in aircrafts and aerospace applications, cooking water pressure reduction, oxy-fuel welding and cutting, in industrial transportation and storing of the LPG gas, and mining industries. Whenever there is a controlled pressure is required at the load side, control of the pressure is required at the actuator side, at the load side, there in every application this type of valve is used. Now look at the circuit where pressure reducing valve is shown. Look at the circuit where pressure reducing valve is shown. Now see, pump is used. That oil in means what? That is the pressurized oil from the pump side. Now 4/2 solenoid operated direction control valves. One direction control valve is to regulate the flow, to direct the flow towards the work cylinder, and one is towards the clamping cylinder. Now work cylinder means what? Which is connected to the tooling side, which is connected to the tool. It may be the press tool, it may be the hydraulic press, means it is connected to the ram of the hydraulic press. Okay, the clamp cylinder. Now see, whenever workpiece is there or job is available and we want to do a tooling, some tooling operation on that job, the first operation is that to hold the job properly, means what? To clamp the job, and second one is to do the operation. Now for a clamping job very less pressure is required, while for actual tooling of that job, for cutting, for bending, for forming, for deep drawing, very high pressure is required. Okay, so according to that pressure, that much pressure is set inside the pressure relief valve, okay, which indicates the system pressure. But during clamping we require very less pressure. High pressure is not required to clamp the job, otherwise it may damage the job, it may damage the workpiece. That's why between the main pressure line and the clamping cylinder line, pressure reducing valve is used. Pressure reducing valve is used. As and when the pressure towards the clamping cylinder side is more, it will disconnect the flow, it will disconnect the main flow towards the clamping cylinder, and by restricting the flow towards the load side, it will reduce the pressure. It will reduce the pressure. Again I am repeating, here two actuators are there. One actuator, that is the clamping cylinder, requires the less pressure than the work cylinder. Now to reduce or to control the pressure towards the clamping cylinder side, in between the main pressure line and the clamping cylinder, pressure reducing valve is used. From the symbol we come to know that it is a normally open valve. Now unless and until the pressure at the clamping side is less than the set pressure in the pressure reducing valve, valve is acting as a normally open valve, so flow is allowed to flow from the main pressure line towards the clamping line. But the moment when from the control signal line or the pilot line pressure built up is more than the set spring pressure of the pressure reducing valve, it will disconnect the valve partially or fully depending upon the pressure developed inside the pilot line or control signal line, and in this way it will reduce the pressure towards the clamping cylinder side. So again, as a summary, for all the valves ISO symbols are there: pressure relief valve, pressure unloading valve where the remote pressure is required as a pilot pressure, then brake valve, counterbalance valve, sequence valve. Counterbalance and sequence valve is along with the check valve, and this is the pressure reducing valve. Now see, what is the difference? Suppose the question is that what is the difference between pressure relief valve and pressure reducing valve? So the first difference is that pressure relief valve is normally closed valve, pressure reducing valve is normally open valve. Pressure relief valve indicates the pressure of the whole system. What is the highest pressure that system can withstand? It can indicate that. In pressure reducing valve, the set pressure is nothing but the pressure required at the actuator side. That is the highest pressure required at the actuator side. Then here the pilot line is connected. See, in case of the pressure relief valve, pilot line is connected towards the input side, towards the main pressure line. In case of pressure reducing valve, pilot line is connected towards the output line. From the output line, pilot pressure signal is there. Means what? From the load side or the output side, pilot line is connected to the valve. Here pilot line is connected from the input side, from the main pressure line. So these are some differences between the pressure reducing valve and pressure relief valve as far as normally closed, normally open, its application and the position of the pilot line. So this is regarding the pressure control valve. So thank you guys, thank you students. So up till now, whatever we have seen in this video is regarding the counterbalance valve, pressure reducing valve and we have seen the counterbalance valve, brake valve and pressure reducing valve. Whenever you will go through this video, you will understand all the things. The video regarding the pressure relief valve, pressure sequence valve and unloading valve, and this second video, that was the first video, and second video is regarding the counterbalance valve and pressure reducing valve. So thank you.